Hey folks, welcome to the Wretched Mess. We've got a bunch of videos for you here. We're doing a test on studs and nuts and all kinds of stuff like that. First we're going to be checking the effect of lubrication on the amount of clamping force you get when you're torquing down a head or a main cap or something like that. Next test after that is we're going to check just how much clamping force do you get when you torque it down to recommended torque. After that we're going to check the strength of nuts. That's something I learned. Some stuff you stay away from, some stuff you want to buy. Braking strength. After you torque it down, how much is left? We've got a gizmo to figure that out. And that also goes along with how much thread do you really need in that engine block before it pulls the threads or breaks a stud. The first test we're doing is the effect of lube. We're going to check it 4 different ways. We're going to check dry threads, oiled threads. Some threads I'm just putting some anti-seize on to see what the difference is. And I've got some ARP lube that ARP recommends for their nuts and washers and studs and whatever. We'll do a little minor test with washers versus no washers. Repeatability. Now that's what we're going to do. Part of it here is torque it down, loosen it up, retorque it, loosen it, retorque it again, just to see if it changes between the first and the second and the third torquings. What we're using here is we've got a chunk of steel that's threaded, the stud that's in it. Now these studs are 9/16. 9/16 sounds odd, but most of what we sell here is the tractor pullers. A lot of tractor engines use 9/16. Some use 14 millimeter, but that's so close to 9/16 that you don't really notice. So we'll put this in our tester gizmo here. Then we're also using a cast iron washer to simulate it's working up against a head or a block or something. And a hardened washer, and then a nut. Now we're going to torque everything to 180 foot-pounds of torque. Now I've done some other playing around here. 3 different click type torque wrenches, 2 different dial type torque wrenches. The click types are more consistent. If you tighten it, loosen it, you'll get a more consistent reading time after time. One thing you'll know with the click type, you'll watch the gauge here, and it'll go up, and as it clicks, it'll jump about 20 pounds of pressure on the gauge. This gauge is not calibrated as it says there. We're just using it as just a reference point, basically. Now this is dry here. Okay, it clicked at 800 pounds of force on the gauge. We'll do it again, see if it changes. Very close to the same reading. Probably 810. Now as I'm torquing this down, you can kind of feel it getting gritty, like it's dragging material along. about 820, which means it goes up just slightly with each use. And you can see some marks. I don't know if you'll be able to see them here, but there's some minor marks where it was dragging, galling on this washer. Now all these threads have been washed in the solvent tank and then cleaned again with acetone, because we want to make sure there's no other lubricant on there. Next up here is oil. Now the oil I'm using is factor number 2. It's not something you're going to commonly find, but it's what I use like in this lathe that's behind me. Milling machines, things like that. This is a machine shop. We'll put a little oil on here, all over the floor, a little in the nut, a little on the face. We want to make sure it's well coated. Okay, let's torque it down and see what it says. About 900. Did you notice how it jumped up a little bit when it clicked? Just about 900. And about 900. We come up with 900, or very, very close, 3 times. So what we're finding here is consistency. Consistency is good. Because you don't have one that's different than another, which is different than another. Okay, next up, we have got Permatex Copper Anti-Seize Lubricant. I have no idea how this is going to work, but we're going to play with it. It's a brand new bottle. Put a little bit on the threads here. A little bit on the washer here, and all over my fingers. There, on the inside of the nut, and on the flange of the nut. very close to 900. And the same 900. And very close to 900 again. So we're pretty consistent here. Okay, next up. Next up is ARP Ultra Torque Fastener Assembly Lubricant. ARP sells this. I think it's good stuff. I really don't use it. I'm not an engine builder, but I want to make sure I'm using the same thing that the engine builders do use, if this is in fact what they're using. Some places use this lube, some places use that lube. We're just kind of setting a standard here. In fact, that's what you'll see down below. We're going to set a baseline on what we're using, and then we'll use it throughout all the rest of our tests. About 950. About 950, or maybe just a hair higher. And 950 again. There, we've kind of set that. I think we'll use ARP lube as our baseline. It gives the highest clamping force for the amount of torque you're using. Not by a whole big bunch, but it's, if you got it, use it. And if I remember right, when I bought that, it cost hardly any more than buying the Permatex anti-seize. So I think we'll just use that as our baseline. From all the rest of our tests we're going to do, we're going to use this. So that's going to be our baseline. The repeatability, it just seems to repeat. The only one that didn't repeat pretty close is when we had the dry threads, and that's kind of to be expected. But oiled and anti-seized, we're pretty close. The RP lube, I guess it does, they brag and blow on it, and I guess they got something to say. It does work a little bit better. You get more clamping force for the same amount of torque. So I hope you enjoyed this video, folks. We've got more coming up. As I'd said, we've got 4 more videos after this. We're going to be doing the clamping force next. That is with a variety of studs, nuts, bolts, fine threads, coarse threads. I think you'll like it. Stop in again.